The next thing we're going to talk about here is statistical sums, and we're going to learn about a new type of notation here that's going to represent a sum. So let's look at this new notation. Statistical sums. The new notation is the Greek letter S. It's known as sigma. It kind of looks like an E to me, but it's a capital letter S in the Greek alphabet. And so sometimes it's called sigma notation, but this represents a sum. So sometimes they call it summation notation. And here's how it's used. Let's say I have a data set with these numbers, 3, 2, 7, 6, and 12. Now what I'm going to do is I'm going to represent this data set with the letter X. So I could call it sample X. Sample X has these 5 values in it. And I do that because I'm going to use the X with the summation notation to represent a sum. And it'll look like this, sum of X. So this notation means add up the values in data set X. And data set X are these values. So I'm going to add up those 5 values and I get 30. So this is just the sum of X. Add up the values in whatever data set you're calling X. Okay, now another sum would look like this. This is the sum of X squared. And what this means here, you got to think about the order of operations. And you're always going to do exponents. So the 2 here, this is an exponent. That means take a number and square it. So take a number and multiply it by itself. And you always do exponents before you add. So if you don't know the order of operations, let me put them up here. Parentheses, and then exponents, and then you're going to multiply and divide from left to right, and then finally you're going to add and subtract from left to right. So these are the 4 order of operations, and exponents certainly comes before adding. So what this means here is you're going to square the number. You're going to square each number in the data set first, and then you're going to add them together. So it would look like this. So do this operation, square each value in X, and then add it together. So squaring just means multiply 3 times 3, and I get 9. 2 times 2 gives me 4. 7 times 7 gives me 49. 6 times 6 is 36. And 12 times 12 is 144. So what I'm doing here is I'm squaring each number first and then adding them together. And when I do that, I get 242. Now, I could do this in a different order where I add the numbers together first and then I square them. But if I'm going to do that, if I want to add them first, then I got to do the addition in parentheses. That's why we have grouping symbols, to say do whatever inside the parentheses first and then do what's on the outside. So in this case, I'm going to add the numbers together first, and then I'm going to square. So I do what's in parentheses, the sum of X first, and then square. And we've already added them together, it's 30. And then when I square it, I'm going to get 900. And this would be the sum of X squared. Okay? So these are really the 3 basic sums that are going to get used over and over again in our different formulas. The sum of X is just adding the numbers together. The sum of X squared is you're going to square the numbers first and then add them together. And then this is the sum of X quantity squared. So what that means is Sum of x quantity means inside the parentheses, add up the x first, take that quantity, and then square it, and then you're going to get that number. But now what we're going to do is we can use those numbers in other, or these sums in other formulas. Let me show you what I mean. Let me take the x values again. 3, 2, 7, 6, and 12. Okay? And now, if I count the number of values in my sample, I have 5 of them. So my n, remember little n denotes the size of a sample. Little n is equal to 5. So what I could do is I could put this together, sum of x, and divide it by n. So what that means is add these numbers up, add up all the numbers in the data set, and then divide by n is equal to 5. Divide by 5. So this would be 30 divided by 5. And that would give me 6. And in fact, do you know what 6 is? If this is a set of numbers, what did I just do to that set of numbers when I added them together and divided by the number of them? I found the average of the numbers. So this is actually the average value for my sample x. Okay, and this is a formula, sum of x divided by n. So this is actually a formula for the average value. And this is why we use the notation, because it would be hard to know how to express a formula for the average. You would have to do it in English. You'd have to say something like the average is equal to, and I'd have to write out the sum of the values in the data set divided by the number of values in the data set. And that could get very, very cumbersome. So this is much easier. So let me give you one other formula that is very, very important that you are going to use throughout the semester. And it's a formula that involves these 3 sums here that we've already calculated. Okay? The formula is this. Okay, and for now, we won't even give a name to this formula. So, but it plays a huge role. I can't overemphasize how important this particular formula is. And all I'm doing here, this is using these sums that I have up here. This is the sum of x squared, which is, we've already calculated it, 242. So I'm taking 242, and then I'm going to subtract it. This is the sum of x, remember, is 30. And then I'm squaring it, and then I'm dividing that by n, and n was 5. So what I'm doing is I'm taking the sum of x squared minus the sum of x quantity squared divided by 5, the number of values. And the sum of x quantity squared is actually 900. So I could rewrite it like this, 242 minus 900 divided by 5. Okay? So you can either do the sum of x quantity squared, or if you've already done the sum of x quantity squared, which is 900, then I could just do 242 minus 900 divided by 5. And then I can just plug this into my calculator. So if I do that, I would get 240, turn it on first, 242 minus 900 divided by 5, and I get 62. So this is a formula that gets used many, many different ways in statistics. And I know it seems a little weird right now, why this combination, but it just is a very important formula, and it gives you a single number. Okay, just like that. So these are the main sums that I want you to be able to do. And so let me give you an example, and I will have you do the sums here. Okay, so go ahead and press pause and then work on these sums. Okay, you're back. And just so you know, this is a daily activity. This is one of the daily activities that you're going to turn in. So let's go ahead. I'm going to do these sums. I want to write out my work here. So the sum of x is, I'm going to just add the numbers together. And when I do that, and I actually have this all worked out. Let me get my work here. So you add all those together, you get 50. Okay, so the sum of x squared, I'm going to take and I'm going to square each one first. And when I do that, I'm going to get 516. Now the sum of x quantity squared, this is just going to be adding these up and then squaring it. So it would be taking 50 squared, and that's 2,500. And I'm sorry, I didn't have it so you could see it. Sorry about that. Okay, so now I'm going to take the sum of x divided by n. So n, in this case, I have to count 1, 2, 3, 4, 5, 6, 7. So n in this case is equal to 7. The sum of x is 50, so I get 50 divided by 7. And when I do this, it doesn't come out nicely. But we're going to learn whenever we take the mean or the average value, whenever we do the average, if it's whole numbers, I'm going to round it to one decimal place. So this would be 7.1. So I get 7.1. And that would be the average value to one decimal place for my data set. And now, finally, I'm going to do this calculation, this last formula. So if I do that, I've already calculated them. This is 516 minus, and this is the sum of x squared, so that's 2,500 divided by my n is 7. So put this in my calculator. 516 minus 2,500 divided by 7. And I get 158.9. And again, I round that to one decimal place. Okay? So those are some of the main sums that you're going to use over and over again throughout this course. So you want to practice those.